Okay, so today we are going to be adding and subtracting rational expressions, i.e. fractions. So we're going to be adding and subtracting fractions. We are also going to be simplifying complex fractions as the last thing we do. And a complex fraction is just a fraction within a fraction. If you have fractions making up fractions, you know, your denominator is a fraction or your numerator is a fraction, or in our case, both your numerator and your denominator are fractions. So you've got a fraction made up of fractions, that's a complex fraction. They're actually not that hard to deal with, and we will deal with them today. Okay. Lowest common denominator, that's the least common multiple. Your lowest common denominator is what you need to have to add or subtract fractions. You cannot add or subtract fractions without a common denominator. Just because we have variables involved, the rules do not change. Anytime you add or subtract fractions, you have to have a common denominator. Just because variables are now involved, the rules are still the same. You have to have a common denominator. And the domain restrictions will still apply. I don't think we actually talk about them a whole lot on today. I'm not going to worry about it as much today. I think the introduction on Tuesday was good. We may be asked about them again today, but I'm not going to really worry about them as much, the domain restrictions. They will be very important when we do the next section, which is solving equations with fractions in them. And there you really have to worry about your domain restrictions because you will get answers that won't work. Extraneous solutions. And your extraneous solutions come from your domain restrictions. So let's do this. Okay, example problem number 1. Find the least common multiple for each pair. So the first two are really just examples of what you're looking for. Least common multiple between 4 and 10 is the smallest number that 4 and 10 both divide into, that they both go into. Now, and you're teaching elementary school kids how to do this. The most common method that is taught is, list all the multiples of 4. Let's see, 4, 8, 16, 20, 24, etc. And if I need to go more, I can go more later. And multiples of 10, 10, 20, 30, 40. And then if I need to do more, I can do more. And I get the smallest number that's on both lists. 20 and 20. So my least common multiple would be 20. It's the smallest number they both go into. That's what you do when you teach little kids how to do it. Okay, when you're teaching elementary school. We can do it a couple of other ways. And what's going to actually help to understand the other problems is to look at it as factors instead. If we list the prime factors of each number and find the ones that match and the ones that aren't there, that's what we can use. So if I want to do prime factorization, and this will actually help with the rest of the problems, which is cross this. So like, for example, prime factors of 9. 9 is 3 times 3. 15 is 3 times 5. So I have the factors that make up 9 and the factors that make up 15. First thing on my list for my least common multiple is any that's shared. I have a 3 in each term. I have to have a 3 in my least common multiples. I had 1 3 in each. I took out 1 from each. Is there anything else that's shared? No, there's nothing else that's shared. So everything else that there needs to be listed in my answer. So that means I have to have this 3 and this 5 also. And then I multiply them together. 3 times 3 times 5, I get 45. And that's my least common multiple. That's kind of how it works with the stuff with the variables. What's shared, what's not shared. Anything that's shared needs to be listed once. Anything that's not shared needs to be listed as well. Okay? So I go down to the next one. 2x and 7x squared. Okay, 2 and 7 my least common multiple is 14. They don't have anything in common. X and x squared. I have one x here. I have two x's there. How many do I need to have in my answer? 2. I need to have x squared. It's the smallest one that they both go into. X squared. When I look at the next one, I have to factor my quadratic first. Any factoring needs to be done first. So this is x minus 2x plus 3. You have to factor your quadratics before you can find your common multiple. Okay. What do they share? X minus 2. So I cross out that, cross out that. So I have 1x minus 2. And then anything else that's shared? No, there's nothing else shared. So whatever's left behind that hasn't been taken care of, that goes in it. So x plus 3.
Yeah.
Nope. Go ahead and leave them like they are. And please, you will have to multiply out numerators when we do our adding and subtracting. Leave the denominators alone. I'll explain why as we go through. Okay, when we get to the next one. I don't advocate multiplying through unless you have to. Otherwise, leave things alone. This one here, I have to factor again. Pull out a 2. Get z minus 4 times 2. What do they both have in common? They both have a z minus 4, so I have to have a z minus 4. And then what hasn't been taken care of already? The 2. This next one's a little more complicated. I have y plus 3, and I have y plus 3 squared, which really means that I have y plus 3 there twice, right? Okay. So first thing I do is what's shared, what's in both of them. I have a y plus 3 in both. I have to put that down. And then, do I have anything else that's shared? I don't. So that means I have to list the rest of the multiples. So I have a 2 from here. I have my 3 from here. And then I have the other y plus 3 that wasn't taken yet. Now, I wouldn't multiply these together, but I would clean it up a little bit. Take the numbers, the 2 and the 3, get 6. And then I have y plus 3 squared because I have y plus 3 twice. I would do that just to clean it up, but don't FOIL out the y plus 3 and distribute the 6. Okay, it's a little cleaner, but it's not completely multiplied out. Does that make sense? Don't get too terribly hooked up on these. This is more of a practice to kind of look what they have in common and what they don't. Okay. Your turn, do those. Okay, let's go ahead and do these. First one's actually pretty easy, 3 and 5. They have absolutely nothing in common. So your least common multiple is actually 3 times 5. Okay. Next one, 6 and 8. The least common multiple would be 24. 4x and 12x cubed. 4 and 12, the least common multiple of 4 and 12 is actually 12. 4 goes into 12. If one of the numbers goes into the other, that's your smallest. 12. And then I look at my exponents. I have to have, because it's the least common multiple, I have to have the largest exponent there. So I have 12x cubed. The next one, factor it out. 2 numbers multiply to give me negative 20, add to give me 1. Y plus 5, y minus 4. And then I have to list. I list what do they have in common. They have a y plus 5. And then what don't they have in common? Y minus 4. This one, factor the 3, the a minus 9. So you get 3 times a minus 3. And this ends up being actually my least common multiple. It's nice when one of your 2 things all by itself is, particularly when you're doing fractions. Okay. The next one, I have 5 and 6. So I have 5 times 6. They have nothing in common. I have y squared, and I have y plus 2, so I pull out one of them. That gives me a y plus 2, and then I still have another y plus 2 left. So I have to have that, so you end up with 30 times y plus 2 squared. I honestly wouldn't get too hung up on this. What's really important is how our applications are in the next couple of steps. If we're actually doing what we're going to be doing next, there's a little simpler method of getting common denominators on fractions. Okay. So example problem number 2, add or subtract, simplify, and include domain restrictions. So I'm actually going to nail my domain restrictions on this one first. X and Y can't be 0. X and Y cannot be 0. Now getting the common denominators. It's actually pretty easy. What is in the second denominator that is not in my first denominator? Y. So I need to get a y into here, so that means I multiply this fraction by y over y. And when I do that, I get negative 7y squared over 3xy. Okay. What is in this first denominator that is not in the second denominator? 3. So I multiply this second fraction by 3 over 3. And I get plus 3 times 4x squared is 12x squared. And then I have 3 times xy, 3xy. I have common denominators now. Now I can have my fractions. Yes, sir.
You don't have, oh, they're on the same side of the equal sign.
Yeah, they're both, yeah. Did you have a, you look, yeah, this, you sure you got it figured out? Because if you don't, ask, because somebody else might wonder too. Okay. So the idea is you got to get a common denominator. And what I do is when I have fractions like this, I go, all right, what's in one that's not in the other? And I multiply the first one times whatever's in the second that's not in the first already. And then I do the same thing the other way around. And it covers everything that's in the denominators. I don't care about the numerators at this point, other than just they're along for the ride. But what's in my denominators? Now I know what my answer is going to have for my denominator. It's 3xy. Because what do you do when you add fractions? You get a common denominator, and you add them, and whatever you have, that's your denominator, right? Now I add the numerators. Negative 7y squared plus 12x squared. Negative 7y squared plus 12x squared. I can't combine them, right? They're not like terms. I might want to put the 12x first and have minus 7y squared second, just to make it look a little prettier, but I don't really care. At this point, what I want to do is, okay, is there any factoring I can do with my numerator so I can reduce? And my numerator cannot be factored at all, so there's no reducing in this fraction that can take place. Sometimes, after you add them or subtract them, you can factor your numerator out and you can reduce. Okay? Sometimes you can do that. You always have to check, and that could just be, all right, 7y squared, 12x squared. There's nothing in common in either one of them. Nothing to pull out, no factoring to be done. I'm done, I'm finished. Okay? But you always want to check, can I factor? Okay, second one. That gives me a little more room. A little more complicated, but not much. Now remember, we're looking for factors, things that are multiplied. When you add and subtract, it's all about things that are multiplied. So I look at this and I go, okay, what is in the second denominator that is not in the first denominator? And if I do this, that would probably make a difference to you, what you say. So what is in the second denominator that's not in the first denominator? X minus 1. It has to be things that are multiplied, not things that are added or subtracted. When you're doing common denominators, it's always things that are multiplied. Just like when you reduce, it has to be things that are multiplied, nothing added or subtracted. This is a factor, this is a factor. Putting parentheses around hopefully helps you see, ooh, it's a factor. What factors are not shared? I have an x minus 1 here. I do not have an x minus 1 here. So I have to multiply this one by x minus 1 over x minus 1. Now, distribute the numerator. You have to multiply out your numerators when you do this. So I do 5 times x minus 1. Gives me 5x minus 5. All over x minus 1 times x plus 2. Leave the denominators unmultiplied. Leave them as the two factors. Trust me on this. The numerators, you have to. You have no choice in the matter. The denominators don't. Leave them in factored form. Okay. Second fraction, same idea. What's in this first denominator that's not in my second denominator? X plus 2. So I multiply the numerator denominator by x plus 2. And I have a minus, so it's still subtraction. And I have to distribute the 3. So I get 3x plus 6 all over x minus 1 times x plus 2. And looky, looky, I have my common denominator. My common denominator is x minus 1 times x plus 2. X minus 1, x plus 2. And then I have to do my subtraction for my numerators. 5x minus 3x gives me 2x. Negative 5 minus 6. What's negative 5 minus 6?
Negative 11.
Negative 11. Watch your arithmetic. Now, before I continue on, I need to ask myself, can I factor 2x minus 11? No, so I'm done. If I can factor it, I need to factor to check to see if I can reduce my final answer. I can't factor, I'm finished with that. Now, I did forget something I needed to do, right? My domain restrictions. X can't be 2, sorry,
Negative.
X can't be negative 2 or positive 1. It does ask for them, so we're going to make sure they're there. A couple more examples before we move on, because they do get a little more difficult as we go through. My first step on this one is to actually factor my quadratic. I need to get my factors. So I factor this quadratic, and I get c minus 2 and c minus c. I hate it. I should go through and change all these stupid c's to not c's. So I don't have a parentheses followed by a c because it always screws me up. C minus 2 and c minus 1. Multiply to give you 2, add to give you negative 3. Negative 2, negative 1. Okay, what's in my second denominator that's not my first? C minus 1. So I have to multiply this by c minus 1 over c minus 1. Now, I have to do c minus 1 times c plus 3. Foil it out, do a little box, do it off to the side, whatever you need to do to multiply these two together. You get c squared plus 2c minus 3 all over c minus 1, c minus 2, and that's minus. What's in this first denominator that's not in my second one? Nothing. So this is my common denominator. I do not need to change my second fraction. It's like adding 1/4 and 1/2. You only have to change the 1/2 to a common denominator. The 1/4 is already there. I don't have to change this fraction at all because I already have the denominator I need. I just need to copy it over. 6c minus 7 over c minus 1, c minus 2, and then I combine the numerator. Actually, my denominator is still the same thing, c minus 1, c minus 2. Because I got my common denominator, you should know your answer. Once you get the common denominator, that's half your answer, right? Every time. and then combine up the numerators. I get c squared 2c minus 6c, negative 4c, negative 3 minus negative 7, 4, plus 4. Okay, I'm going to pause for a second, go back to the original problem. C can't be 1 and 2. Now, is c squared minus 4c plus 4 factorable?
Yes.
Yes, two numbers multiply to give me 4 that add to give me negative 4, negative 2, and negative 2. So I can factor this into c minus 2 times c minus 2. The only reason I do it is to make it easier to reduce my fraction. So I can factor this one. I do need to factor this one to see if I can simplify my fraction. Can I simplify my fraction? Yeah. I have a couple of c minus 2's that cancel. So my final answer is c minus 2 over c minus 1. And that is my final answer. I can't do anything else no matter what anybody else wants to do. My answer is not 2. But I bet somebody would do that if this was a test question. Take a perfectly good answer and screw it up. Because they have to be multiples to simplify. Not adding or subtracting. The c's do not cancel. Not too bad so far, right? It's really not as bad as it sounds. You have to be able to factor your quadratics. You have to be able to multiply your quadratics. If you can do that without too much trouble, this stuff isn't that difficult. It really isn't. Getting a common denominator is not really that hard if you can do quadratics. If you can't do quadratics, this is going to be painful. Okay. So same thing on this one. My first step is to actually factor the second denominator. Two numbers multiply to give me 15, add to give me 8, b plus 3, b plus 5. And I'm going to tell you, when you have a situation like this, you already have a single factor here, that is hopefully going to be one of the two factors in your second fraction. You really, really, really want that because you don't want to have everything have to be it. Okay, you're going to hope that this is one of those. Okay. Anything in the second denominator that's not in the first. B plus 5. So I multiply them both by b plus 5. B plus 5 over b plus 5. And b plus 5 over b plus 5 is actually 1, so I'm not changing what it's worth. I'm just changing how it looks. You do have to FOIL that out. Shortcut for FOILing when you don't have any numbers in front. B times b gives me b squared. Add the 2, 5 plus 2 gives me 7b. Multiply the 2 to get 10. And my new denominator is b plus 5, b plus 3, b plus 5, b plus 3. And then my second fraction, there is nothing in my first denominator that's not already there in the second denominator, so I don't need to change my second fraction. It's a nice thing to not have to change both of them. So I just copy it over. B minus 4 over b plus 5, b plus 3, and then combine them up. My denominator, still the same, b plus 5, b plus 3. My numerator, b squared, 7b plus b gives me 8b, plus 8b. And then 10 minus 4 gives me 6. Is b squared plus 8b plus 6 factorable? No, there are no two numbers that multiply to give me 6 that add to give me 8. So I'm done. It's not factorable. This is my answer. Okay? too terribly horrible, I hope. Your turn. Do these first two here. Don't worry about going on to the next two on the next page. Do these two, we'll do them together, and then you'll go on and do the next two. Oh, I did not do the domain restrictions on the last one, right? Yeah. What would they be? What would the domain restrictions be? -3, -5. Thank you for bringing that to my attention. So yeah, do these two here. Don't worry about going to the next page and doing those until after. All right. So my domain restrictions, A and B can't be 0. That's an easy domain restriction. What's in the second denominator that's not in the first? A B. So multiply this one by B over B. And that gives me 5B over 3AB for my first fraction, plus what's in the first denominator that's not in the second, 3, so I multiply by 3 over 3, and I get 6A over 3AB. Combine them together, my denominator is 3AB, because it's the common denominator, and then I have 5B plus 6A. And if you had 6A plus 5B, that's okay too. I cannot factor my numerator, so I'm done. There's nothing to reduce, nothing to factor, finish. And usually that's what happens with these. Okay, this one's a little uglier. Yeah, it's a little uglier. It's not bad, but it's a little uglier. It's not bad. So what's in the second denominator that's not the first? X minus 1. You got to remember, these are factors. So I have x minus 1, I multiplied out. 2 times x minus 1, 2x minus 2, all over x minus 1 times x minus 3. Minus, and then what's in the first denominator that's not the second? X minus 3. And this one's, like I said, a little more goofy. So I take x squared times x minus 3, gives me x cubed minus 3x squared over x minus 1, x minus 3. And then give myself a little more room. My denominator, x minus 1, x minus 3. And then combine up like terms. And I want to put it in standard form. There are no like terms at all, so it's basically put everything down, but watch the negatives. You're subtracting x cubed minus 3x squared, so that's actually negative x cubed, and minus 3, that's actually plus 3x squared, and then plus 2x minus 2. Ooh, that is factorable. Oh, it's ugly, but it's factorable. It is. I don't expect you to see this, but it is factorable. Factor by grouping. So I'm going to do my factoring off to the side, so to speak, a little bit here. So if I group these two together, and if I pull out a negative x squared, actually, it's not it is factorable. It doesn't do any good. Never mind. Scratch that. Forget it. Because you pull it out, you get x minus 3, and then you do it over here, you get x minus 1. But you know what? That doesn't do any good because there's no common factor. You're done. Forget it. I was wrong. My bad. It's not factorable. Yes.
Only some of your positives and negatives are like the 3x.
Nope. Because it's minus x cubed minus negative 3x squared.
Okay, what about the 2x?
Why is it minus that? I'm not subtracting it. I'm not subtracting it. Right? It's this minus that one. The subtraction does not go to anything in front, only to what follows. Right? What are my domain restrictions? X can't be what?
Oh, 3.
Do those two. C and D, top of the next page. Okay, let's do these. So the first one, I need to factor the first quadratic here. Two numbers that add to give me 4, that multiply to give me 4, add to give me 4. D plus 2, D plus 2, technically D plus 2 squared, but it's easy for what we're doing here to leave them as separate factors. And once again, you really, really want to hope and you really want to try that whatever your denominator is on 1 is at least one of the factors here. That should help give you a starting place if you're not sure about the factoring. So anything that's in the second denominator, not in the first? No. So the first fraction does not change. So I get 3D plus 1 over D plus 2, D plus 2. I'm going to go ahead and leave it as D plus 2 for the moment. And then what's in the first one that's not in the second? A D plus 2. So I have to multiply by D plus 2 and D plus 2. So D minus 1 times D plus 2 gives me D squared plus D minus 2 all over D plus 2, D plus 2. And then combine them up. I'm going to go ahead and do the D plus 2 squared here, just to make it look pretty. And then I have to combine up my like terms. Now I do have a negative that I'm subtracting that. So I have minus D squared. 3D minus 1D gives me minus 2D. 1 minus negative 2 is plus 3. Is that factorable? Maybe. But my factor choices are limited. My only possible factors end in 3 and 1, right? Because two numbers will multiply to give me 3, 1 and 3. Those are my only choices. So if it does factor, 1 and 3 have to be my numbers I factor out. They're not going to cancel with 2's in the denominator anyway. So even if it is factorable, it won't make any difference. I'm done. And my domain restrictions, D can't be negative 2. Okay. I think it's factorable. Pull out a negative first. And then it is factorable, but like I said, neither one of the factors cancels, so it's not worth it. Okay. Second one. Factor my second fraction. Two numbers multiply to give me 5, add to give me 6. X plus 5, X plus 1. Okay. So what's in the second denominator, not in the first? X plus 1. So my first fraction, X plus 1, X plus 5, slow down. That's to me. Multiply X plus 1 times X minus 1. Sum and difference exactly the same except for plus and minus. So I get X squared minus 1. Plus, there is nothing in the first denominator that's not in the second denominator, so my second fraction does not change. X plus 1, X plus 5, and X plus 3 in the numerator. Add them together. X squared plus X minus, plus 2 all over X plus 1, X plus 5. The top doesn't factor. Two numbers that multiply to give me 2 that add to give me 1 doesn't work. Okay. So I can't factor it. I'm done. And X can't be negative 1 or negative 5. You do, like I said, want to check to see if it's factorable and see if any factoring can cancel. Okay. Questions? Okay, now you are about to learn why you invert and multiply when you divide fractions. Okay. So these are compound fractions. I want to simplify the compound fractions. Now, actually naming my domain restrictions goes really easy here. I'm not allowed to have 0 in any denominator. 2 will never be 0. Negative 4, x minus 4, x can't be 4. And then because of the setup I have, this numerator, because if this numerator here were 0, it would make the whole thing 0, which would make my whole denominator 0. I'm not allowed to have that, but I don't have to worry about it here either. This is my only domain restriction. Now, here's the thing. I don't like fractions divided by fractions. I don't like them. Nobody likes them. So here's what we're going to do. We have a compound fraction. You get rid of the compound fraction. Make the denominator of the big fraction 1. So you'll have something over 1. And if it's over 1, it doesn't matter what's in the denominator. So I'm going to take 2 over x minus 4 and make that into 1. You do that by multiplying by the reciprocal. You multiply by its inverse. And you multiply top and bottom by the inverse. See what I did here? I inverted and multiplied. This is why you invert and multiply when you divide by a fraction. Because technically this is x plus 3 over 2 divided by 2 over x minus 4. To make this 1 here, that cancels out. I get 1, and look what I have. I have my original numerator fraction times the inverse of my denominator. I inverted and multiplied. This is why you do it. This is how it works. Okay? And now I multiply. There's nothing to cross cancel. So I get x plus 3 times x minus 4 all over 4. If you really want to FOIL out, you can, but I would suggest you don't. Yeah, invert and multiply. That's all we're doing here, inverting and multiplying. Yeah. Yeah, you don't have to multiply it out. Leave it in factored form. And if you can reduce and cancel, it's in factored form. You can reduce and cancel, it's in factored form. All you're doing is inverting and multiplying. That's really what you're doing here. And this explains why you invert and multiply, because I want to multiply the denominator by the reciprocal to get 1. And if I multiply the denominator by something, I need to multiply the numerator by that same something, or I change the value of the whole fraction. So that's what I'm doing here. So on this one, same idea. I multiply, and this one I can actually reduce ahead of time. I'm not going to worry about reducing the fraction. I'm going to say, hey, I'm multiplying by 4 times m plus 2 over 2. And if I do that to the denominator, I need to do that to the numerator. Because whenever I do the denominator, I have to do to the numerator to keep them equal value, right? These cancel. And now I have multiplying 2 fractions. Okay. Now, this one here, I need to factor my denominator here. So I get 5 over m plus 2 m minus 2 times, and here I don't factor, but I can reduce the 4 and the 2, right? 4 and 2, they reduce. 4 over 2, divide them both by 2, I get 1, and I get 2. So I get times 2 times m plus 2 over 1. That's what that ends up being, right? Because my 2 in the denominator went away. Cancel your m plus 2's. And I get 10 over m minus 2. That simplifies down. And my domain restrictions, m can't be plus or minus 2 from this, because this denominator can't be 0 here, and this denominator can't be 0 here, but I've already got that covered. The minus 2 is already covered, and this entire denominator can't be 0 either, which means my numerator here can't be 0, but I don't have to worry about that. Okay. Invert multiply, that's what you're doing. Okay. And one more example before we move forward. Same idea. My domain restrictions on this one are goofy. X minus y cannot be 0. X minus y can't be 0. If I add y to both sides, x can't equal y. As long as x and y are not the same number, I'm okay. Because if x and y are the same number, I get 0, right? Anything minus itself. If x and y are 0 or the same number, I get 0 in my denominator. If they're not, I'm okay. As long as they're not the same number, we're good. So now I do my multiplying. This one I multiply by x minus y over 8. And if I do that to the denominator, x minus y over 8, these cancel, which is nice. And then I multiply. And, ooh, looky, looky, looky. The x and y cancel. And 2 and 8 reduce. So I get x over 4. Oh, isn't that pretty? Something nice, sweet, simple. Almost everything is gone. Okay? Yeah. Invert multiply. Compound fractions are actually very easy to deal with. Okay? They're very easy to deal with to get rid of to get just one fraction. Questions? Okay. Your turn, do those 3. Okay, let's do this. For other reason, I want to make sure you have enough time to do your quiz. So, first one, my domain restrictions, x cannot be 0, cannot be 1. Makes it easy. Multiply by 5 over x minus 1. 5 times x minus 1. Those cancel. I can't reduce anything there. So I get 15 over x minus 1 squared. If you want to do x minus 1 times x minus 1 as the denominator, you can. Or x squared minus 2x plus 1. On to the next one. Y cannot be plus or minus 1. Can't be minus 1 for here. And here I have the difference of 2 squares. Can't be plus or minus 1 for that. I multiply by y plus 1 over 3. Y plus 1 over 3. Those cancel. So I have 4. And factor the y squared minus 1. Y plus 1. Y minus 1 times y plus 1 over 3. The y plus 1s cancel. And I get 4 over 3 times y minus 1. Invert, and then do the multiplication that you did on Tuesday. That's all it is. You factor and you cancel, just like we did the multiplication that we did on Tuesday. Your first step, the only difference between this and what we're doing then is you're taking the denominator, flipping it over times the numerator. That's it. This is division of fractions. This is what we were doing on Tuesday. Same thing. Flip it over. You have to factor, cancel your factors. Whatever's left is what's left. So if I do this next one, okay, S can't be 0 because that'll give me 0 here. And I also can't get 0 here in this one. So what I want to do is I want to multiply by S to the 4th power over, and I'm going to go ahead and factor the denominator here. When I flip this over, I'm going to go ahead and factor it out. 3s minus 1 is one of my factors. I hope, and it actually is. I get 3s minus 1 and s plus 3 are my 2 factors that I get. And if I multiply the denominator by that, I have to multiply s, not x, s plus 3. The numerator by that. Numerator and denominator multiplied by the same thing. These cross cancel and go away. So I just have that being multiplied. And then I cancel and reduce. 3s minus 1, 3s minus 1 cancel. I have 1s here. I had 4 of them here. That now becomes s cubed. So I get s cubed over s plus 3. And s can't be 0, s can't be negative 3, and s can't be 1/3 because I can't have 0. I cannot have 0 here. I cannot have 0 here. I cannot have 0 there. The only place I'm allowed to have 0 is in the very tippy top. Nothing else can be 0 at any time. Okay? Thus endeth the lesson.